Hello everyone. Today we are back with another good question. It's based on binary tree, and the question is straightforward. There's not much of complexity in explanation, but yeah, if the logic doesn't strike you in the first go, it is definitely going to be a little tough. So we have to basically find. This is also a standard question. We have to basically find the whether the tree is symmetric or not. So how come a tree is symmetric? So this is one. So symmetric in the sense the left subtree should be the mirror image of the right subtree. So basically 2 we see it matches, 3 matches this. See, if it has to be equal, 3 will be matching this particular node, but it has to be symmetric. It should be mirror image. So 3 will be matching the this corner, and 4 will be matching the immediate corner. This is, let's say, it's like keeping a mirror over here. So a bit of optics involved there, but yeah. So in the first go, I was thinking that we have to perform some types of in order traversal. So like, for example, if I, for this particular example only, if I go ahead and try um, in order traversal, so it will be like 3, 2, 4. This was my first attempt, which failed for a few of the cases. One, so it's like basically having the left node, root node, right node, and then again start doing the same thing. So it will be 4, 2, 3. So I thought of doing it this way. So at the end, in the whole list, what I've created, I'll compare the like I'll compare it in the reverse order, like 3 if 3 matches to the last element, if 2 matches to the second last element, if 4 matches to the third last element. If this continues, if this trend continues, I will return true. Okay, this is a mirror image, but this fails on few of the test cases. For example, like let's say if the numbers are repeating, I can even show you that example. uh, yeah, so let's say if the numbers are repeating in this way, 1, 2, 2, here I have 2 again, here I have 2 again. So you can see this is not a mirror image. This, you can say this looks kind of same. This is not a mirror image. By our understanding from the past of optics, we know that the mirror image of this will be this. So basically the 2 has to be here, okay, not on this side, for the whole left subtree to be a mirror image of the right subtree. So I actually was able to figure out a better solution, a more what to say, a more correct solution for this. So that correct solution is, we'll create a function called defsolve, and in this function, what we'll do is we'll have uh, two nodes, n1 and n2. Okay. And we will simultaneously proceed in both the directions. So for example, if it is 1, so in the solve function, we'll proceed in the left as well. To the next call of the solve, we'll proceed to the left as well, which is 2, and we'll proceed to the right as well. So it's like 2 and 2. So we are here. Okay, so we from the root element, we pass to the left, we pass to the right as well. And then in the next solve call, what we'll do is, and we'll compare whether 2 is equal or not. In the next solve call, what we'll do is we'll go to the left of this, that is 3, and the right of this, that is 3. Okay, we'll compare these two. Then what we'll do is we will go to the next. So next, since both of them are none, here also it will be none, here also it will be none. So I can maybe increase the size. Here also it will be none, here also it will be none. So what will happen is, since they both are none, will return true. So we are comparing in the way of in order traversal itself. Like, we'll first compare the left node, then we'll compare the root, then we'll compare the right. But yeah, it is, we are doing simultaneously on both the sides. So it's like, here it is null, here it is null. Okay, so we go in the next solve stack and we see that both the node n1 and n2 are null. Basically they both are null or none, whatever we want to say it. So since both of them are none, so we'll return true. Okay, we'll return true. And then we'll compare the root node. So value of root node in both the places is 3. So we will basically say that yeah, we'll also return true. So, and then we'll compare the right node. So right node of this and left node of this, they both are also none. So we'll return true again. So that's the basic scene. Like we have to go to the left and then we have to compare the root. Then we have to go to the right. The only thing we have to keep in mind is we have to do it simultaneously. So we can even see the solution quickly. So solution, you can see if n1 and n2 both are none, then we are returning true. If n1 and n2 either of them are none, then we'll return false, because this should be the case, because we are anyways traversing in a symmetric way. Okay, so we are traversing on the one side in the left, on the one subtree we are traversing towards left, and on the other subtree we are traversing towards right. So either both can be none or both can have the equal value. It cannot be like one is none and one is not. That's like saying ki I have a 4 over here and I have a none over here. So this is anyways not symmetric. We see that when we put a mirror in between, they both are not similar. So either both have to be none or none have to be none. Okay. So that's what we have done here. So if n1 equals to none, n2 equals to none, both are none, then we return true. Or in these two elif statements, we have proved that if either of them are none, then we'll return false. And the other scenario is return. Then again, we are doing that traversal. Like one traversal is like n1 dot left and 2 dot right. Okay, so we are anyways proceeding in the mirror image format. Like from 1 we reached here and here, from 2 will go for n1 will go on the left and for n2 will go on the right. And once we have reached the root, or once the left has been traversed, and we return to the root, like 3 3, once we see that it is same, we return to the root. Then we also compare the root. So basically at the end we are returning whether the left and right on both the subtree are same or not, and n1 dot value equals to n2 dot value. So if they both are equal or not. So like let's say if everything was fine, here it was 2 and here it was 8. Like let's say this 2 was 8. So of course the image looks symmetric, but the values are not same, so it is not going to be a mirror image. So for that purpose we are also putting this as n1 equal n1 dot well equals to n2 dot well. And then again we are traversing in the reverse order. Like we'll go to the 4, we go to the 4. The only issue here is that for the root node, basically the whole solution will be calculated twice. What will happen is I compare whole of this structure to whole of this structure, then I come back to 1. Since I'm passing root comma root to the solve, I come back to 1, and again it starts doing the same. So at root it searches whether root dot val equals to root dot val. Yes, it is equal, but again it starts doing the reverse thing. Like it will go to the right of the root element and it will go to the left of the root element. So basically it's calculating the answer twice. I thought it might create an issue, but I went in and submitted it and it looks like there was no problem. So yeah. So yeah, this is how it works. And the previous approach which I explained is definitely not the one we can follow. I had like 195 of the test cases out of 199 passing, but still, yeah, I won't say that was the correct approach. So yeah, that's all. Thanks a lot for following till now, and please like and subscribe the channel. Thanks a lot.